here will be giving a talk how to build your backbone. So the presentation is about to start. Pay attention, okay? Bye.
So, good afternoon. A couple of people know me here. Not everyone. So in the presentation I'm going to talk a little bit who I am, what we do, what I do personally, what we do as a company. What I have been doing in the past, this talk is about the backbone, it's about our network infrastructure, what I'm going to do in the future, and also what is nice to have, what functionality I want to build in, what I want to extend. So first of all, a question around, just raise your hands. Who has noticed that we use public IP addresses on this conference? 6 people. Who has actually tried to figure out more about those IP addresses? 4 or 5 people. Great. So, who am I? I run an internet service provider in Switzerland, and obviously, as you can see, I can extend it to Serbia. That's not a problem. We're going even to extend it to the Telenor data center in Belgrade in the future. At the moment, I operate the AS number 58299. AS numbers is basically your identifier in the internet. The internet is not a series of tubes, it's a mesh network. Everyone connects with everyone, but you should be unique. So in order to be unique, you get your AS number. So this is my identifier, this is my sign. Our network, we started in 2012. We got IP addresses from RIPE. Last year we actually started. It took me 2 years to actually get all the routers together, to get the money together in order to buy internet lines, in order to buy connectivity from ISPs. If anyone wants to connect to us for social networks, I'm going to send you the link later on. You can also find me on the C3 NOC help desk, so if anyone here has been on a CCC event, it's the same account anyway. So, back to what we do. So we operate this backbone in Switzerland. What is a backbone is the first thing. Well, you don't order your own lines, you don't lay your own fiber, that's too expensive. You normally work with carriers, you normally order a line. So for example, in order to get from Basel in Switzerland to Zurich in Switzerland, well, you have to talk to somebody else, they give you 2 network ports and it's virtualized on their network. I use this backbone for events. I run the backbone on this event, I run the backbone on DESCON a couple of weeks ago. How do you do that? Well, I don't have a fiber line to Switzerland. All we have is VPN connections. So wherever there is a need for a conference, we normally connect to that. And we have our own internet. Nobody does any filtering. It's completely open. So what do I need the backbone for? We do colocation, like Hetzner does, like other people do. We rent out domains, we have web hosting. Well, the usual shit, you know it. It's nothing spectacular. Also consulting, nothing spectacular. So, what have I done in the past? So, in order to get your own network up and running, well, somewhere you have to connect to somebody else. I had to create BGP sessions. Who here has been on one of my BGP workshops? 3 people. So you know about BGP. That's great. I actually had to do the workshop in order to teach myself how to do that, because nobody teaches you how to do BGP. There's books about it. The books are 5 centimeters thick, and you're like, okay, I have to learn this before I can actually use it. I cannot remember a whole book on theory. It's horrible. If you want to play around and if you want to learn about it, just as I said before, try to connect to the DN42. It's definitely worth to learn about it. That's what I did. I did my own setup by learning in this private VPN test network. So I learned how to connect to Init 7. For those people who don't know Init 7, they're currently launching as a business and private customer as well now. They get a lot of fiber connections in Switzerland. They're selling bandwidth to people like Hetzner, to large enterprises. And it's actually nice. I mean, if you get a network connection here from, say, SBB, have you ever walked into an SBB office and talked to the network engineer who should solve your problem and you had a coffee and afterwards your problem is solved? Not really. Well, if you want to do business on a smaller scale, you need to find an ISP like that. That's what I did. I can walk to those guys and hey, if I need something special, you know how you can get them to do something special? You bring them a whole box of Clumate and they do it for you. Or they say, okay, forget about the setup fee. So I got this backbone, I got it connected to Init 7. I have a colocation in Zurich that's, by the way, about 100 kilometers away. And now I extended it to Glattfelden, that's close to the German border. So, pretty difficult to see, but here's a picture. So, if you want to get a backbone done, it starts to be rather difficult. First of all, you have to connect to different data centers. So I have the colocation in Zurich. I put servers in. I got from one of my clients actually a ring that connects to Basel. Basel is one data center. I got 2 fibers that I can use for my own to another data center, and I have to connect back to Zurich. As you can see, Equinix 1 is again in Zurich. So in order to connect from Zurich to Glattfelden, I have to go through Basel. Does that make sense? Not really. That's 200 kilometers for nothing. But it saves money. I have to pay only on that VLL service and on the uplink. So far, so cheap. You see any redundancy on this? Nobody sees any redundancies on it. That's the problem. Except, well, the ring is protected, but still if Basel dies, it doesn't really help. So what should you do in order to make it more redundant? Well, different things. First of all, internet exchanges. Internet exchanges is something nice. If you want to avoid that the NSA is watching all of your communication, make sure that you get an internet service provider who keeps data local. In Serbia, there's SOCs. So if you're with, say, Telenor, and you're chatting with somebody on SBB, and both Telenor and SBB is on SOCs, it never leaves Serbia. Your packets go to Belgrade and back. That's it. Very simple. And best of all things, those service providers are most of the time pretty cheap if you have those internet exchanges. You pay for a port and you peer with all of them. Well, shorter routes is keeping data local. It also has a second advantage. If you don't have to go through Frankfurt, for example, hey, your latency is better. Better ping times. Hey, you can kill the other body much faster. So, I decided I will go to SwissIX. This is scheduled, so I can keep the data locally in Switzerland. If anybody wants to see more how the situation is in Serbia, there's a talk that has been done by RIPE members about the internet in Serbia. So, next thing, Cogent. So, Cogent is a so-called Tier 1 ISP. So, you have a couple of ISPs, everyone is a mesh, and you have to connect to other people. But how does that work? Who pays whom? So a Tier 1 is an ISP who doesn't have to pay anyone else for connectivity. They only have to pay for probably investments on their fibers, they have to pay for power on their routers, but they get a shitload of money from all their clients connecting to them. Why? They've been early on the game and they have a lot of connections to other people. So I decided I connect with Cogent. It's a so-called tier 1. They have about 5,000 more direct connections. I'm one of 5,000. If you remember back, I have the number 58299. It's 16 bits. 16 bits means 65,000 individual standalone networks in the world. It's a little bit low number. We're running out of 16-bit AS numbers, but still, there's about 50,000 individual networks on the network. So if I can connect through one ISP directly to 10% of the internet, which is the large part, it keeps the route short. Short route means lower latency. Hey, you're faster in killing your buddy again. Same thing. Next thing, TV Factory. That's random ISP. You don't know it, that's clear. If you have large telecom providers, Telekom Serbia, Deutsche Telekom, they're normally pretty asshats in the internet. Why? Everyone connects fair and equally on those internet exchanges because it saves money on both sides. If you're like the large ISP in a country, like especially in Germany, Deutsche Telekom, well, are you interested that the other body saves money? No, because you could think, well, my clients are the majority of clients for ISPs here. So if the other people have content, they have to pay me. Both sides pay. I get double the money. Well, in Switzerland I have the same problem with Swisscom, with Cablecom. So I had to pay another ISP like me, who's a bit larger, who pays actually those ISPs to connect close. Why? Well, if I have clients that use Swisscom or Cablecom or just the large cable providers, I need short routes. So that's the next thing. I need more uplinks. So if you remember, I have init7 as uplink. I'll get SwissIX, I get Cogent, I get TV Factory. That's a lot more redundancy than before. What could we do more? Well, one backbone is nice, but what if you do a mistake? What about two backbones? Well, I managed to get a new number, which is, by the way, very simple to remember. 41 is Switzerland, 666, the number of the beast. I don't know how I will call my backup backbone. It's the second backbone, but I think I'll do something funny with it. So the next thing you're going to do is, fine, now you have a backbone. But what does it serve? I mean, it's fun. You have a couple of routers, they generate noise, they move around packets, but yeah, they use power costs, so you need clients, right? Somebody should pay you for that, because otherwise it doesn't work that well. So actually now I do connect downlinks. So we have fiber to the home ISPs in Switzerland that actually buy connectivity from me. That's coming soon. Now, if you have two backbones on the same lines, you end up with a big mess in the routing tables. For people that have been playing with routers, VRF and VPRN is the same. So basically, you start to virtualize your backbone. You have one line, and you split it. You virtualize it. That way, better resource usage. It's like you have a server where you virtualize two machines. They don't influence each other. So this is coming soon. This is actually coming soon, like this month. All of that. Sounds like a stressful month? Yeah. That's how it's going to look like. You see that somehow we actually end up something that nearly resembles a ring, right? Ring is nice because if one line fails, we can use another line. Interaction, that's a new site. I cannot afford redundancy there yet. The one on the top right corner, that's our low-cost colocation. I cannot afford a second line to it either. So, We have a ring. Have you ever played by accident a cable twice in your switch? Who has done that? Plugging in a cable twice in your switch? Come on, everyone. Seriously, everyone has done that. What happens? The switch is blinking like crazy. Well, what actually does happen is you have a lot of management communication. Hey, who has this IP? The ARP protocol. If you have a loop in your network, well, that packet gets sent round and round and round and round, and it keeps on going, and it crashes your backbone. There's a solution for that, supposedly. Well, it's called spanning tree. Spanning tree is nice, right? So, in order to avoid a loop, well, we could just like cut one of those lines off. We just block one line. We don't have a loop anymore. And if it goes over, we just switch. Right. Nice in concept, really bad in actuality. Because you need to steer it a little bit. Every single switch who participates in spanning tree, you have a priority because you want to have the strongest switch to be the root. It's like a tree, spanning tree. You want a solid trunk, not a little branch, and then you have suddenly a tree on it. That will fall over. Well, that's the thing that normally where the big fuck-ups happen. Because if you have on the top right corner a small internet line over there and you do a mistake on spanning tree and you decide to reboot one of your routers and suddenly all traffic ends up there and you're like, where do all my packets go? Why is everything so slow? Well, you end up starting to dislike spanning tree. About 90% of my network failures have definitely been spanning tree. So, that's one thing to consider. Spanning tree is dangerous. Perhaps there's a better solution for it. Let's see. So, that's how it's going to look this month. What do we want to do in long term? Well, we just heard that spanning tree can be difficult. There's a second problem. Spanning tree blocks lines, right? So I have a line I'm going to pay for, but I'm not going to actually use it. That's a waste of money. I don't like that. Well, what you can do is, instead of using VLANs in your core, you can use different protocols. Instead of Ethernet, let's use MPLS. MPLS is basically something between OSI-Layer-2 and OSI-Layer-3. It's label switching. So at the moment, we have those virtualized routing tables. Let's split that out and go to MPLS. If you have MPLS in the core, you have a ring, and it actually takes the shortest path instead of the only path. Better capacity, better latency, all the resources are used, and hey, we don't have spanning tree blocking me. So, core on MPLS, that's a layer 3 core, as you normally hear. There's two strategies. Either you say you want your core on layer 2 or layer 3. I'm going on a layer 3 core. So, next thing which is very important, BCP 38 and 84. I'm going to have another talk on that as soon as I've actually implemented that. I'm still learning that. So, here on the Congress network, we have 151.216.40/23. That's IP addresses we got for this Congress network. One of the things which should not happen, because then there's something wrong, is if my firewall, here, the core router, sees that there's a packet coming in, source IP from the Congress network, but it's actually coming in from the outside. That's definitely something wrong. And also, if my router sees, hey, there's a packet leaving my network, but that's none of my IP addresses, that should be dropped. And this is best practices guide, and this should be implemented. Why? There's the problem with open DNS servers. If somebody sends a spoofed packet to a DNS server with a spoofed source IP address, the DNS server, because it's UDP, will reply to it. But because the source IP is spoofed, it replies to a victim and not where the packet came from. And normally the answer is much bigger than the question. That's a so-called amplification attack. It happens with DNS, it happens with NTP. It's a big problem, especially on those management boards. If all the ISPs in the internet would actually implement that, there would be no amplification attack anymore. And we're talking about hundreds of gigabits of amplification traffic. It nearly took down CDNs in the last year. So everyone has to implement that, and I should do it as well. Next thing, hey, we have this core on MPLS. Well, we still have the problem if you have VLAN going from A to B and you end up having a loop by accident because you connect two switches and you forgot the switches are connected on somewhere else through your backbone. Well, let's do it differently and use some form of VPN. It's a layer 2 tunnel. So what I'm buying from other people, I can create on my own and sell it again. So if I have an Ethernet connection from A to B, it's actually some form of VPN. That's one thing. So, next thing, DDoS attacks. Well, very bad if you get an DDoS attack coming in. Now imagine you have a 10 gigabit line from your ISP attacking, and you get an attack of 20G to your server. Some server in your network gets attacked. Well, even if you say, okay, I just dropped this traffic on my router, is that going to help? 10G line, 20 gig traffic, you're out. The only solution is that I actually ask my ISP, who connects me to the other people, to filter that traffic. At 2 a.m. in the morning, will they be happy if I wake them up? Not really. BGP blackholing, I send them a specific route, I give it, not kidding, the number of the beast, I tag it with 666, everyone does it with that, it's bad packets, you tag it with the number of the beast and they know, okay, that's a black-holed IP, so we drop traffic to it. Suddenly I don't have a problem anymore, and it doesn't cost me. Because 20 gig on my line, that's going to be expensive. If it filters out, doesn't cost me. Very nice thing. Next thing is we're also going to do layer 3 VPN. That's the long-term solution. That's especially for customers that want to have nice VPNs, but they don't care about encryption. Why is this relevant? Well, this is how it should look in the future. We have those 3 red routers. They're going to be MPLS routers. I don't really want them visible in the internet. They're not relevant to the customer service, so let's hide them. So the idea is we have those blue routers. They are the actual routers that connect to the internet. And everything in between, let's use a VPN. That way, even if we have an attack on my backbone, the core is not affected, the core is not to be seen. If the core is not routed in the internet, nobody can access it. Saves you on lots of firewall rules because, well, it's not visible. So this here will be a ring. We have here uplinks, we have uplink to the right. So still, we have a lot of redundancy, but we are not going to have spanning tree across the network. One big rule. And we're not going to have a layer 2 core. We're going to use VPLS, we're going to use Alcatel routers for that. I got them for free, which is nice. And this whole thing will be 10G. Things I learned during a setup of a backbone. I recommend not to do that if you ever do a big network, and that can also be a campus network. Have a good VLAN strategy from the end. Not just like, oh, what VLAN could I use? Oh, that VLAN is free. Well, let's use it. I created a big mess. I still have a big mess. I have to clean that up. VLAN strategy early on is going to help you. Otherwise, it's really messed up. Next thing, IPv6. So IPv4, you have hardly any addresses. So you use them as resourceful as you can. You split it up, you split it up, you split it up more. V6, we have enough IP addresses, at least for now, but it's much bigger. If you have a subnet from RIPE or any other local registry, you're supposed to actually say, okay, we have those bits. I cannot change the first couple of bits. That's your prefix. The part you cannot change, that's called a prefix. After that, I have potentially a couple of bits. In my case, 96 bits for free. I can use whatever I want to do. 64-bit is in a regular network. That leaves me 32 bits left to play around with. And I just started, okay, network 1, network 2, network 3, but in decimal. That's a big mistake. You should split it up like, okay, 3 bits is the country, 3 bits is the city. You actually should split it up like that. And I completely messed it up. Great if you have to renumber your whole backbone and you have to tell every single customer that he has to change his DNS records because he's going to get new IP addresses soon. I tell you, they love you for that. Another big mistake I did, so yeah, you have all those devices where you have to access a management network. A switch has to be configured. Well, normally you use private IP addresses in order to split it because it should not be accessible from the public internet. Nice in concept. Bad if you actually leak those addresses by accident into your own routing table, because, okay, the internet cannot access your management IPs, but every single one of your customers can. That got some interesting effects, don't ask. So the idea is to use a different routing table again, so it does not mix. So, like a server with virtual machines, we have backbone 1, backbone 2, management network, and they cannot jump to each other. And again, avoid spanning tree if you can. Search for other functionality. At least don't do spanning tree through your network. No spanning tree in the core. Nobody's going to patch there anyway. Try to only have spanning tree on the switches where clients access it. Don't do spanning tree on the uplink ports. It has nice side effects. Yes, it's a good concept, but it messed up more than it solved. What I normally don't see on slides, if somebody does a presentation, is what actually equipment people use. And I'm always interested in on my own. So for people who are interested, we're using Alcatel core routers. Those core routers do about 200 gigabits on their management board. You have 10 gigabit slots. And the big one, Service Router 7, you actually can put in 100 gigabits cards. So I think 100 gigabit is still, yeah, that's going to last a couple of years, hopefully. We never know. Core routers, well, my core switches, they fell off a trunk as well. Somehow I got a lot of equipment. So I got switches that can do 720 gigabit switching routing for free. It's very nice if you know actually manufacturer who switch out equipment because they're upscaling. So sometimes it's worth to ask on the trade-in. Your supplier, if you know that your supplier does trade-ins, if there's actually stuff that gets traded in, if you can buy that. Sometimes they give it to you for free. On the switches, Brocade, these are very, very solid switches. 6430, that's you can get it with 48 ports at about $1,500. They've never let me down. They work as rock solid. 6450, it's about $3,000. They have 10G uplinks. Those are like the workhorses in my network. I use them for clients that need 100% reliability and they want to spend some money. For my routers that connect to the uplink, I think you guys have a lot of Mikrotik here in Serbia. It's very strong. Why? They're really cheap. At the moment I use the 36 cores models. Just imagine a CPU with 36 cores. It's very nice. And I'm going to the 72 core model soon that has 8 times 10G ports. Well, I mentioned that I'm going to upgrade to 10G this month. I realized a couple of weeks ago, oh, I'm going to buy 10G, but I don't have a router with a 10G card. Not a BGP router, just the switches and the core routers. They're not the edge routers. The edge routers are outside of your network. They're connecting you to the other. So I have to trunk lines together. That's not a good solution if you have to bond lines. Not for a production environment. Also stuff that we use, extreme switches. We use it here as well. We have I've used that for the workshop. I got them for free from other ISPs. It's very nice if an ISP actually gives up business and goes bankrupt. You can catch up quite a bit of equipment. Alcatel, the same, Cisco switches. And for management network, actually unmanaged Netgear switches are really, really nice. So, why do I do this work? Why do I get a second backbone? What would be nice? Well, you know, the government normally asks ISPs about their customers if they think they have an investigation going on somebody. I operate a larger Wi-Fi network in Switzerland. Well, I have a couple of lawful intercept requests, but it's boring. I only get like 1 or 2 a month. I mean, that's not like the record in Switzerland. I would like to break this record. So bring it on. I get this second backbone because I don't want to risk the primary production for some nice stuff. What about Tor exit nodes? Hey, if the government is asking me for Tor exit node every week, I don't care. If I can tell them, well, that was this association, you have to go there. And then the association says, well, okay, we're boned. We give up and we create a new association. Well, you can play around a little bit with it. I think that would work pretty nicely because most of the time it's actually a liability issue. So create associations. I give you the internet connectivity. Tor relays, that's just traffic. Research nodes, somebody want to scan the internet? Fine for me. Crypto services. Switzerland at the moment is still pretty nice in terms of law. We might change it. We might lose out that you don't have to spy on your customers, but we're actually fighting it pretty hard. Freifunk, a lot of people probably heard about them. They want to create free Wi-Fi networks. Nobody wants to be liable for it. Well, create an association, create 1,000 associations. I don't care if I have to deal with the government. Why? Hey, let's make a living out of it. The government pays you $250 for every question they ask you. Bring it on. I could live on that. I don't care. Enemy of the state? Yay. Yeah. Also, we do quite a bit of sponsoring for different organizations like the Freedom for, Initiative for Information Exchange. Yeah, we have quite a few associations in our backbone already. So, if anyone wants to contact me, here's a couple of contact information. I think send me encrypted emails if you can. It would be worth it. I have a Twitter account, that's my private one. I have an email address here. So, from my point of view, I'm up for questions, I'm up for feedback. If anyone has some feedback on the backbone or ideas or questions on decisions, wait for the microphone.
How much AS number costs to make this?
Okay, so first of all, to get an AS number, you either need to find a friend who is a so-called local internet registry. Local internet registers are members of RIPE, because we're here in Europe, so for us the RIPE is relevant. Membership for RIPE is $3,000 in the first year and $1,600 in the upcoming years, or euros. I think it's actually euros, sorry, euros. But the actual object, to have an AS number from RIPE, €50 for the AS number, but an AS number is boring, it doesn't help you. You also need some IP addresses. You can ask for an IPv6 subnet without being a member. That's €100 a year. Talk to me, there's a standard contract and you can actually peer in the internet.
Okay. But exchange points, like socks,
Yes?
live here. When you buy connectivity to socks, you only have peering to the local providers, but you don't have downlink to the real internet.
No, that only to the people that participate, yes.
Yes,
That's the idea of an internet exchange. You always need uplinks as well. An internet exchange is meant as a neutral platform, and they most of the time explicitly forbid to do transit. It's called transit if you go outside.
Yeah,
they
I
normally
understand
forbid
it.
it. So you need uplink providers. But you don't want to pay your uplink provider. If all your traffic is locally, you want to save on money.
Okay, but what if I want to go to Facebook? I need the...
You always need an uplink. Yeah. If you want to go to Facebook, actually it depends. Facebook actually peers on some places. But still, you want the whole internet. You need at least one uplink. That can be a local other ISP, but it must be a private connection.
Okay, thanks.
More questions?
What kind of router are you using to connect to the exchange?
Well, at the moment, I'm not yet connected to the exchange. I'm thinking about using either an old Brocade router I have, which has, because to connect to the internet exchange, there is another problem. So BGP routers, the edge routers, they need to hold the whole routing table in the internet. That's more than half a gig. So you need more than half a gig of RAM just to hold the routing table, plus you need the operating system on top of it. So you need at least 1 gig of RAM. But to connect to an internet exchange, all you get are the local routes. So I can use a router with 500 megs, or if you want to, you just use another Mikrotik. So probably CCR 1036 again.
At Mikrotik user meeting in Prague, there was one Italian, I think, user who connected with Mikrotik on the exchange. So probably a good idea. And he explained how he did it. And
Yeah, I'm using Mikrotik even as edge routers,
Yeah.
and it's a peering router. So yes, I've been on this Swiss Mikrotik user meeting recently as well. That's why I know that this 72 core model is coming up.
cool thing.
I have another question. Where I can learn about BGP? Real BGP, not the theory and stuff.
A real BGP, DN42. That's this VPN network. I think it's just DN and the number 42. You can connect to it. All you need is a public IP address somewhere. You can rent a cheap VPS. And basically what you need to find is someone else. You establish a VPN connection, and from DN42, DN42 also uses private addresses in this VPN. You get your own block from within DN42, and then you start building a first VPN connection, you build a BGP connection through DN42. That's one thing, but you want more than one connection. So you start talking to somebody else in DN42, you build a second VPN connection, and you build a second peering, and so on. DN42 is a big mesh network, and that's how I learned getting online. That's one way. The other way is you go to talk to one of the local internet registries, like I am one.
This is in Serbia.
Hmm?
This is in Serbia.
It doesn't have to be Serbian. You talk to an internet registry. You pay them those €100 for the objects, and you get an actual AS number, and you get a V6 block. Forget about V4. You don't need V4 to learn, and you connect through VPN. Nobody says that you have to use like Ethernet connections. You can use VPN as well. And then you're on the real internet. But if you do a fuck up and if you do announce IP addresses that you should not announce, you can break the internet.
Okay, that's
Remember Pakistan Telecom. Pakistan Telecom, a couple of years ago, announced IP addresses from YouTube. I even know why it happened. They created a route in their edge router, just a routing table entry, to point to nowhere. But they forgot that pointing route to nowhere is normally the way you get a big block and you want to announce the whole block. So what happens is their block by accident went on the whole internet. So they basically what they did was saying their router, hey router, these IP addresses are mine. Don't send them out. Very efficient to block YouTube from Pakistan. But what they did by accident was telling the router, these are mine IP addresses, and by accident they told the whole world. That's dangerous. You can work on filters, so your ISP that connects you to the internet also has to be careful. So if I do a fuck up on my own, believe me, I do enough mistakes in my life. That's why I'm telling you. My uplink provider said, hey, this guy is announcing something wrong. I think I'll block that. So you actually have whitelists.
Yes,
It's very fragile. It's a very fragile system with those whitelists. Because if you have whitelists, then you have to bring on a Congress network. You have to talk to all your uplinks. Please adjust your whitelist. I'm going to use this network for a weekend, but I'm keeping everyone busy for 15 minutes to fix the whitelist.
Okay, but we now in BalCCon, we have a VPN connection to Switzerland or Norway.
Switzerland.
Switzerland, but
Yeah,
why is Norway?
what the hell is going with Norway? That's not my
Google
thing.
sucks.
I don't know what happened with Norway, because what I did was, first of all, the IP addresses show Bletchley Park. That's some piece of history for everyone here. I did geolocation on longitude and latitude to show to the airport Schiphol in Amsterdam. The language for the IP addresses is set to French. So whoever gets French websites, I had fun. And the IP addresses are registered to point to Serbia. So the country code is Serbia. And my company is based in Switzerland. That's why geolocation doesn't work.
You have the AS number here in Serbia too.
Yes, we got a separate AS number. So the setup like this here, you can have on your own at home.
No.
Just talk to me.
Okay, we now have a VPN to Switzerland.
Yes.
And that's
And from there on to the internet, exactly. And we have one AS number here, and that's the BalCCon AS number. That's not 58299, that's the second one. 50 something, I don't remember.
When you have one SN number, you can make others by...
No, you only get one. You get one or more AS numbers, but you cannot create AS numbers out of it. You only need one.
But how then BalCCon have S number?
I asked Tribe. Seriously, I asked Tribe, hey guys, I have this Congress, can you give me IP address AS number for a month? They do that.
They are really nice guys.
Temporary assignments, that's meant for congresses, yes.
But another question, why we have VPN to Switzerland? What's the magic?
Why Switzerland?
Why
Because
VPN?
Why VPN to Switzerland? First of all, because I control the endpoint. Second thing, this is Serbia.
Yes, I know.
I didn't know who's going to be our internet service provider, and believe me, to do a BGP setup takes weeks. I had to prepare it. The VPN was something I could control, because it doesn't matter on what line I'm here. I can switch it here from SBB to Informatica and everything, and it will still work. That's why, preparation.
Okay then.
More questions? Well, otherwise you have my contact information, just hit me.